Okay, can you guys see this? Anyone?
Yes.
I can.
We're good. Okay, so I am going to cover some of the lower level stuff about how pieces hook together. So if you look at how things are glued together, we have something like Python on top that uses JPy to talk to the JVM, and we have our Deephaven Java code running in the JVM, and we'll spend most of today kind of talking about this. So JPy is a Java to Python bridge. So using it, you can call Java from Python. You can also call Python from Java. So this is an open source project that we administer with a consulting firm that produces code for the European Space Agency. I guess an important detail here is that you can allocate primitive arrays in one language and use them in the other without copying. So this ends up being useful for all sorts of things, including performance. Okay, so here I have some example code. So if you look here, I've imported JPy. The next thing I'm doing is I am using JPy to get the big integer Java type. And I've just assigned that to the variable big integer. And then using that, I go through and construct an actual Java big integer. And if you look down at the bottom here, you can see, oops, I'm messing things up. Anyway, if you look down here, you can see that Python recognizes this as a Java type. And you can then, using that object you've created, call the underlying Java methods, and JPy will do the dispatch to the proper method for you. So for example, here I've squared the number BI, and again, that returned object is a Java big integer, and JPy has made that transparent to the Python user. So in our code, we've tried to hide the JPy stuff as much as possible if you're using Python. And so types are defined in the Python code, just like this second line here. But occasionally we run into cases we forgot to cover. And we also run into cases that may be specific one-off things that we don't want to generalize. And we need to document those cases. Let's see. Okay, another technology here is Numba. So Numba is an open source just-in-time compiler that works with Python and Numpy. And under the covers, it's using Llvm. Do any of those, does everyone understand all of those abbreviations?
What is LLVM?
Okay, so LLVM is a low-level virtual machine. So it's basically an open source compiler backend. So you take some sort of intermediate representation of a programming language and pick an arbitrary piece of hardware, and it can compile that onto the hardware. And so you could have just a generic x86 processor, or it additionally supports the vectorized extensions. It also supports compiling to GPUs and all sorts of things. So you can take some code, translate it to intermediate representation, and then LLVM works from there. So LLVM's the back end for most of the new languages. So if you look at something like Swift or Rust or Julia, that's all backed by LLVM.
Okay. Got it.
Okay, and it can be used for either static or runtime compilation. Any other questions on those things? Okay.
Can you just can you expand a little bit on the third bullet point about avoiding the GIL?
Yeah. Okay. Yeah. So anyway, with Numba, you can get C-like speed from Python code. The other thing is, while Numba is compiling, it can look at that particular block of code and determine whether Python locking is necessary for that bit of code. And if it's not necessary, it can produce compiled code that doesn't need to hold the lock. That doesn't mean we're taking advantage of all of these things, but could be useful.
Okay, got it. Yeah, okay.
Yeah.
That's the last part that, got it.
Yeah. And then I've got this little graphic on the bottom right. Like I mentioned, LLVM can use the SIMD vectorization on the chips. That's one way it can squeeze out a bit of extra performance. I don't know how well we're using that with the vectorization or with the chunking. Jianfeng may be able to tell us. Or not.
I don't know. What is SIMD?
Single instruction, multiple data. So these processors have like this AVX 512. I think that's a 512-bit data register, and so that you can perform like multiple floating point operations at a time, or something like that.
I don't think we do anything, specifically for this. We just use numbers decoration and let number decide what to do. Yeah.
Okay. All right. Okay.
But presumably Numba, yeah. I mean, presumably Numba is like, you're handing it code, and you're handing it pseudocode. You're handing it, bytecode. You're handing it bytecode, and it's going to go implement that bytecode the way it best thinks for the processor it's running on right now.
Yeah.
And maybe that involves SIMD, and maybe it doesn't.
Right.
And hopefully it does. Right.
Yeah, hopefully it does. So the one area that I had a question about was, we're doing chunking stuff on our side and then handing that over to Python, and it's possible at the boundary we're not optimal, but maybe we are. So,
I don't think there's anything special there. We pack all the data into a continuous chunk of memory and just hand it to the vectorized function.
Okay, yeah. So you then assume that Numba is hopefully doing everything possible.
Right. And just to be clear, we only use a very limited set of options number. All these GL or parallel equal to true, all that kind of things. I don't think we can really take advantage of that. Just the.
Yeah. Okay. Here I just have a Numba example. If you look at this looks like regular Python, except it has an annotation here. And that annotation, you can look at the import, comes from Numba. And so just by adding that annotation, that marks this method as being one that's going to be just in time compiled. All right. Other things we care about are Numpy, which is a Python array library, Pandas, which is a Python data frame, TensorFlow and PyTorch, which are both machine learning libraries. Then if we look at what that means in the general scheme of things, we basically have two languages here. We have Java and we have Python. We have JPy, which lets those two talk to each other. And then we have we have the machine RAM. In that RAM, you can allocate a primitive array, and either language can use that. So for example, in Java, you can create a primitive array and then treat it like a Numpy array. And you can do all that with 0 copies. You can get good performance. There is one thing to be conscious of, and that is both Java and Python are garbage collected languages. And so in creating this memory and referencing it, you need to establish ownership somehow so that both aren't trying to garbage collect it. So that's just a note of something to be conscious of. Go ahead.
Do you have an example of using? My question is, what is the prime use of this facility?
Of the arrays. So if you look, so if you look at our TensorFlow implementation, TensorFlow is a Python library where its guts are written in C, and somehow we want to take data from our tables and efficiently hand it off to TensorFlow. And so, writing a function to copy data into the arrays would be slow in Python, but you can write it in Java and it would be fast. So in this case, you can create an array, fill it in Java, and then hand it over to the Python C library, and it does its thing. Does that make any sense?
Yeah, I don't know. I mean, as far as I can see, so far we do copy. To avoid memory issues, we copy the at least at the Python level. For example, the table to data frames. We do make a copy of the data in Java, then pass it over to Python.
Yeah, and if you look at the stuff that's for TensorFlow, it's not copying.
It's not a copy. Okay.
Yeah. So I mean that's something to keep in mind while you're looking at that is you may be able to avoid copies this way as well.
Do we have any instances where the two garbage collectors cause an issue? If, for instance, you've got a Python data thing where you pass it over and you're going to use something Java, and then Java thinks it's done with it and garbage collects it?
We don't right now,
Okay.
but I'm sure, one minor mistake that could happen. Yeah, and that's one of the things that JPy is doing is it's, trying to manage these things.
So can I could use like a little context, right? Like these are all things that we're using internally to implement Deephaven, or these are things that customers can use, or these are, or some of both, or what?
So Numpy, Pandas, TensorFlow, and PyTorch are all client things. They're super popular in the data science world.
Sure.
And so they just need to work.
Yep. But you're telling us about them now because we expect that customers use them.
Yeah,
which I totally believe, or we've actually implemented Deephaven in terms of these libraries.
We expect the customers to use them, and I'm mentioning it here just because we're talking about how these different things interact, and I wanted to mention how the memory space looks for this.
But quite specifically, Mike, no, Deephaven is not implemented in terms of these libraries.
Okay, great, good, that helps.
Yeah.
So I guess one of the things you said very early on, maybe in the second slide, like there's a bunch of JPy that you want to hide,
right?
And that, I don't know, that freaked me out a little bit because it's pretty awesome, right? Like you can, like I think one of the demos I saw was like, well, no, wait, I need this from Python and I need this from JSON, I need this from Java, and I want to intermingle and exchange. And it's sort of mind blowing that you can do that, right? It's sort of amazing that you have that power. And I mean, that's something, do you really want to hide that? You don't want to hide that. You want people to use it, right?
Yeah. So I think we want people to use it, except for things that they're going to be doing it all the time. And then they'd be typing too many characters.
Okay. So then encapsulate it and wrestle it to the ground and then make it easy. And then.
Yeah.
Okay. Okay, great. Yeah. Thanks. Got it. All right. I'm there. Sorry, I'm so remedial all the time.
No. I appreciate the questions.
The fact is I don't know anything and I have to ask. So.
Okay, so then kind of on an unrelated topic, we regularly have clients that want to use C or C++ in Deephaven queries, and specifically in Deephaven query strings. So the Deephaven query strings execute Java, and So to make this work, you have to make the C or C++ libraries callable from Java. And in Java, there's an interface to deal with this interaction, which is called Java native interface, and this is what the code looks like. It's some of the most awful stuff you've ever seen. So in an ideal world, we will never deal with JNI explicitly. So there are tools for making this easier. One of the popular ones is called SWIG, which is Software Interface Wrapper Generator. And this is basically, you take one language, you take another language, and this spits out boilerplate to make it so that you can have these languages talk to each other. On the good side is it's popular, it supports a lot of languages. On the bad side is it is very cryptic and it is buggy. And when things go wrong, it can be nearly impossible to debug. So if you look at what you would do, here's an example for a C++ interface. So you can see they've got their own custom definition language here with % signs that mean things and includes and whatever. So here it includes the header files, and then it goes through and auto-generates that JNI code for you. Where if you have a large language, this saves tons of time, or a large library, it saves tons of time. On the other side, tweaking these files to work ends up being quite hard because C++ natively has 10,000 different types, and then when you start having those things, you need to include special syntax here to make them work. Any questions on SWIG before we charge ahead? No.
Is there any reason there's not a puke emoji on this slide? Because this looks even worse.
Yeah, maybe we need a puke emoji.
There's many emojis. I mean, there's a couple thousand, so you could pick.
Yeah. Okay, so then, so another way to do this is JavaCpp. This is less popular. It's got a C++ focus. On the plus side, in my experience, it just works. This is used by Vola Dynamics, which I don't think you guys are familiar with, but they are a vendor we work with that sells a pricing model for options. Anyway, if you look here, I have a link to the open source repo for it. I also have a link to a repo I created that shows how to integrate JavaCpp with Gradle. And so that may be something we want to write up at some point. But if you look at this, this is much easier. So here you just have Java code, and you have an annotation that says what the include file is. You have a couple other annotations. You tell it to load the library. You have another annotation that says, oh, this string is in fact a C++ string, so handle that properly, and then it just works. Then we may have people that want to support other languages, things like Go or Rust or what have you. And most of those languages can be compiled down to a binary interface for C. And because of that, you can wrap those libraries like C. And in Go, I have two examples here. The Go example on the left, you just do the import C and then mark the functions with what they should be exported as. And then on the right, I have Rust. You just label the function as, don't do name mangling, and mark it as being C, and then you can go from there. So when we inevitably have people that want to use these languages, it should not be hard to integrate them. We've just never done it. Right. Any questions? That's what I've got today. No. All right, Pete, you normally have questions about integrating things.
Yeah, no, I mean this one's sort of the advanced class. Whenever I talk about this, it's just, well, I mean the Python data science stuff is a pretty well-worn path. The rest of it is like, oh, it's magic, and you can call a C++ application by using one of these wrappers, and you pass, data objects into the application from Deephaven, and it all just works. And it's all compiled down to Java is the way I think about it. But, any of the details related to these wrappers is certainly beyond the scope of things I'm tracking. And
So go ahead.
Some of the enterprise examples that JJ went over, we could take the essential inner part of that was for the enterprise and apply it to the Deephaven part, right? Or I guess it'd be nice to see an example of being able to use it in the IDE.
Being able to use which in the IDE?
C or C++.
Yeah. So that's a question I have for Pete, and that is, in the documentation timeline, how important is it for us to cover, integrating these other languages? And I'm asking that specifically because we're targeting developers at the start. So,
I think priorities matter a lot because the universe of people and use cases we think we're relevant for is really quite enormous. So who do we attack first? My instinct is the first people the first people I want to attack are people that, hey, I have a Kafka stream and I don't like my database alternatives for doing stuff with those Kafka streams. Because that's an easy headline for us to talk about. And it feels like adjacent to that are people that know Spark, and Kafka and Spark are more than anything else. There are large Java communities and ecosystems around those two products. And I think targeting that first will be, plenty of work for this group. From there, the next two constituents are C++, and because there's Arrow developers there, and then all the Python data science people, once we think we are sufficiently able to service them and without polluting our story, let's say maybe in the fourth quarter or something like that. In regards to the C++ community that hangs out around Arrow, I honestly don't know whether these bridges and wrappers are really important, or whether it's it's simply important to support pretty basic data in, data out from a C++ client where Deephaven's at the center. I really don't know what those preferred workflows will be like, but it feels like Java is the first thing, and these are certainly, what you described here is either data science stuff, which is, I think, quite straightforward, but should not be a priority until the fourth quarter. And then the wrappers are really kind of an advanced class.
Right. Okay. So
does anybody wildly disagree with that? You guys, this is to a certain extent where we want to get to, is that the DevRel group begins to form an opinion about where do bunches of people and bunches of use cases exist for which we're relevant. I know that that's sort of impossible for anyone to weigh in on, but we certainly don't need to rely exclusively on Pete Goddard's impression that, hey, Spark and Kafka are a big deal. Those two things are certainly our closest neighbors, and it seems like they're mostly, they're more a Java conversation than any other language. So let's just start there. That's my knee jerk.
Yeah, I think the only thing to consider is, Galileo is using wrappers, and I think it's just a question of how frequently we expect that to be reproduced. Certainly on the data science side, it'll happen.
Right. So a smart data scientist I know once told me, developers kind of break down into the really smart people that can do interesting stuff, and then a lot of copy pasters. That guy's name was Chip. I think we want to make sure we can target the copy pasters. And I think these types of things are, we want to make sure that nothing else the copy pasters can get something done. And this stuff feels well beyond things that they'd be involved in. So, that's, my guess is we can start on easier use cases around whatever. I have Kafka streams and I want to do some stuff. I have Parquet streams. I want to do some stuff. I want to write a little Java application or maybe a Python client that is not doing data science things. It's just doing table operations and the like and producing output.
Right.
I mean, that is and again, people can speak up in the coming weeks. Like, I think that's a story. Without getting into the, at least the 200 level class that we're talking about here.
Anything else to discuss on these?
Yeah, is this presented as using this is advantageous over just using the C++ API if we're going to port it to OSS, or are we doing this, or is this wrapper stuff just to reach a broader audience?
So the wrapper stuff is so that you can use it inside of a query string.
Okay.
Does that make sense?
Yeah, that's what it seems like from what you went over. I didn't know if there was any other advantage, or this was more of, we just want to have the capability to do both. I don't know what, especially if we're targeting developers, I don't know what the development community looks like that uses this type of thing. It seems like Pete said, it almost seems like this is more geared towards data scientists who don't really want to just do C and C++ and whatever else all the time.
Yeah, the use cases we've seen have been things like, somebody has a fast numerical model developed in C++, and they want to call it within a query. So they want a query to pass parameters to this model and then get the results out of it, which may be more frequent on the data science side.
Or the quantitative modeling side, at least, Yeah.
Sure.
Yeah. I mean, just to nail your comment, JJ, like this is certainly not a replacement of the C++ API, right? So I'm sitting there, I have a C++ client application. I want to interact with Deephaven. I want to send it stuff and then get back data. You're using the API for that. It's by send it stuff, like send it instructions to do things, right? Those instructions that do things server side can be sent via these APIs, or it could be in a code studio or whatever the case might be. Typically, they're a combination of table operations and Groovy, or table operations and Python. If you want them to be something else, regardless of how they got to the server, they need to have one of these wrappers involved. And I'm sure that was all really obvious, but it helped me to say it one more time and not get corrected, and then I'm sure I kind of have it right.
Right. Mike, any thoughts, since you dig in the weeds frequently?
So I like it. So now that I have context understanding what you're doing, right? I mean, it just seems like we're allowing any customer to use whatever's familiar to them or whatever's most appropriate for their solution. And that gives you more customers, right? It gives you more customers and more use cases. And I think it's awesome. It's got to be a pain in the ass to support, though, right? I mean, like if you do any little thing that breaks any one of these libraries or add-ons or integrations, then you got to worry about that.
Yeah, we haven't broken much.
Really?
Fortunately.
It's amazing. I mean, that's surprising to me, right? I mean, you're just to be commended. I mean, it's fun to write code, but when you're writing code against someone else's rules and like, oh man, you can't use this data type because it makes this inner operation sick with JVI, and it's a pain in the butt, right?
That also tells you that it's probably not that heavily used. I don't think it's of that high value compared to, let's say, platform integration. This is language level integration. So, by platform we say, Kafka and all this other, data streaming stuff that probably can bring us more, value than just doing this. So for open source project, this is definitely not high priority. That's my take.
Agreed.
All right, anything else?
So when, like if I create an array, or like a Python array or something in the Deephaven IDE, is it JPy that allocates the memory for that Python array? Or is that pure Python that stays away from Java entirely?
Okay, so the Python array you're talking about is a Numpy array.
Right.
Okay, and it depends on if you have Numpy created
Uh-huh.
or you have JPy created, depending on which
I see.
constructor method you call.
Okay. Interesting. So there are several ways to do that.
Right.
Okay. And does the user care about that, or is that something that we care about? Like, do they need to know that they can allocate an array either way? Or
I don't know that they care.
I wouldn't think so. I wouldn't, as a user. Okay, yeah, that makes sense.
Amanda, any questions?
Nope, it's really cool to see kind of all the stuff you can use. When I think I start to understand, there's just more added to it, which is kind of impressive.
Right.
So one thing Jinfeng just said that triggered a thought with me is, and it's just probably a question we can all just walk away with. It's somewhat timely. So as I just said on a different call, Confluent is IPOing tomorrow. So Confluent's the company behind Kafka, Apache Kafka. They're going to IPO for $10 billion, which says, hey, they're a big deal. We know they're a big deal. They also happen to be the technology that is probably most adjacent to us. Maybe not in terms of every use case, but in terms of telling a story, there's lots of stories we can tell. Most of them rely on words like easy or good or fast or the best. And as soon as you have to rely on those words, you don't have a story because everyone thinks you're a liar. But, one story we can tell is about real-time data. So that is our first story. We need to get traction on that story, or subsequent stories we tell won't matter. And in regards to real-time data, Kafka owns that story. So we need to figure out how to piggyback on their story, not to compete with it. And we're lucky because it's incredibly front of mind, as the $10 billion IPO suggests. However, what Jinfeng said is right. Like, Kafka is sort of, there's two ways to use Kafka. One is, hey, you locally run something, and now you have controls over your Kafka streams. Or the other is you launch a Kafka platform as a service, and now whatever, some stuff is flowing around and being federated, and you're getting events to applications through that service. The way in which, hey, some user manages a Kafka stream local to a Deephaven instance, and then you can inherit those updates and those events in Deephaven, and we can do cool stuff with them as updating tables. All of that seems rudimentary. I mean, it's very straightforward. But what do we need to do to support, you have Kafka as a service somewhere, you're paying congruent or congruent, I don't know how you pronounce it, for Kafka as a service in AWS. You just read about Deephaven, you think it sounds cool, you want to use it on your Deephaven streams, on your Kafka streams. How do we make that easy?
So, I think that ends up working out to being not too difficult. I mean, the Kafka interface, you kind of tell it where to look for something, and then
so we're just giving it like an address, and then where it's sourced kind of magically doesn't matter.
And the security handshake.
Yeah, we probably need to develop a connector or something that can pull the Kafka stream into our table in memory.
Right, and I think to a large extent, again, when you think of like a local Kafka stream, I think to a large extent we have that in enterprise. It'll be ported in a much better fashion over to or in a different or slightly improved fashion OSS. If the platform stuff comes for free, or the platform connection comes for free once you have the locally managed connection done, then that's great.
Yeah, there's really no such thing as local Kafka.
Okay.
It's just stuff that's running somewhere, and it needs, an address to get there, plus the security protocols to get through.
Yep. Okay. Fantastic. I mean, to focus your minds on, hey, I want to get out of documentation world and I want to start producing material that people care about, like whatever. If somebody had a blog right now that said, Deephaven is the best database for Kafka streams, and you could put it out there right now with a great story and examples of side by side us doing something and Kafka doing something, you could literally send it to a lot of people today that are thinking about congruent as an IPO, and they'd say, holy smokes. And they'd found out like, oh, this is just a bunch of small team doing stuff. It looks pretty cool. It could get noticed. So just focusing your brain on, advocacy and community building, that's our leading thread. It won't go away tomorrow after the IPO. It'll be the leading thread, I think, for the next several months.
Yeah, and I think we're blocked on that until Ryan gets his stuff moved forward.
Oh, right. Yeah. Kafka won't actually exist in OSS until end of July. And we start telling stories in August. It'll be, you guys will have 12 hours to turn it around. Good luck.
All right.
But to be clear, sorry, and I know I talk too much. I'm not suggesting you do anything. I'm suggesting you think and investigate and try and understand the community around Kafka. There's nothing that Ryan is going to deliver in the next 6 weeks to illuminate the people on this call about ways to connect with people that might care about the intersection of Deephaven and Kafka. And if we were to rely on Pete Goddard for insights about that, then we should all just, close shop, because my insights are not going to be as valuable as yours in that regard.
Yeah. And I have some Kafka examples, which I should send out to everyone, just so people can play with it. Okay, so for the next one of these, are you guys interested in Jianfeng going into more depth on Python and related things? Or would you like me to try to get Charles to cover Kafka and SMB?
I would suggest, if I could offer a third alternative, I would suggest Parquet as a warm-up for Kafka. Okay. Because not to say the two are particularly related, other than they're both data sources from our point of view, but Parquet is mostly done. I think we could do a combination of Amanda Christian, and it would be a good exercise to have Amanda. We all know the best way to learn is to teach. So if Amanda could teach us what she has known about Parquet from her last couple weeks of work, then Christian comes in and does heavy lifting, then we all know something about a data source that is, conceptually pretty darn easy to understand, at least. And then that's good fodder for the next one, in which we move into Kafka.
Okay, sounds good.
Would you be up for that, Amanda? And again, it can be like the way all of us have done so far. You're not going to get points for polish. It's going to be substance, right?
I didn't know there was points available. Wow.
Yes, there are points. Matter of fact, you get 1 point for that witty remark right there.
Yeah, I could throw something together for Thursday.
And it might be you and Ryan, but you and Christian is better because he's just good at, he probably has time a bit more available. So I'd really, reach out to him and figure out the way the two of you want to do it, because I think we want to understand his stuff, not just yours.
His stuff still goes over my head, so that's good.
Right. Well, fair enough. Yeah, I think of it as, you're representing a user and he's representing the technology the user relies on.
Okay, I'll see if he's free for the Thursday meeting.
Beautiful.
All right.
Thanks everyone.
everyone.
Cheers. Bye.
Bye.